In this video, we'll quickly walk through the drive configuration just so you can get a feel for the flow and see what's involved. We'll then walk through the tools you have available to help you debug and monitor the system, and then we'll use the jog tool to jog the motor to see if we wired everything up correctly. This video picks up where the hardware video left off, so if you haven't seen that one, you'll want to do that first. I also want to encourage you to check out the family overview video where we outline all of the features and capabilities of this servo system. It's amazingly capable for such a budget-friendly servo system. Now, could you use the drive's LED display to punch in the parameters we need to configure the drive? Sure, but it's much easier to configure the drive using the free configuration software, which is why we'll be using that software to set up the drive in all of these videos. So if you haven't done it already, go to AutomationDirect.com and find the L7C drives from LS Electric. You can either click on this to go directly to the documentation, or click on any drive. I'll click on this one and scroll down. Here you'll find everything you could want to know about the servo system, the specs, the drive user manual, the quick start guide, which is awesome by the way, brochures, templates, firmware upgrades, CAD drawings, etc. In particular, this is the configuration software. Download it, install it. The drive should be on, but if not, go ahead and power it up. Connect a USB cable from your computer to the USB port on the drive. You can use any USB-A to mini-B USB cable, but I want to encourage you to use this one. Why? Because it comes with an optical isolator that ensures noise from your PC won't interfere with the operation of the drive, and vice versa. A standard USB-A to mini-B USB cable will work, but when you have issues, you won't know if they're coming from the PC or not. With a recommended cable, you won't have those worries. And you can always remove the isolator if you want to test using a standard cable or the optical isolator doesn't cooperate with your system. Bring up the drive configuration software. Now what you see here will depend on what option you have selected up here. We'll get to those later. Click on this guide to connect to the drive. If the software finds the drive, the icon will look like this, and the drive information table will now be filled out. I'm going to go to Setup, Return to Factory Setting. That will reset the drive to factory default so you know exactly where I'm starting from. Yes, we really want to do this. Give it a few seconds, and when it's done, you can either power cycle the drive or hit this guy to reset the drive's control electronics. We'll do that because it's quicker and easier. Resetting the drive's control electronics clears out any residual stuff that might be lingering and gets you a good clean start, so don't forget to do that. To configure the drive, under the Quick Setup menu, click on this Setup Wizard. This wizard is going to walk us through these steps to give us a fully functional servo system. Now in this video, we're just going to take a quick spin through this so you can see what's available. We'll spend more time on each step in the other videos where we actually set up the drive for the different modes. First step, we want to be online. Do we want to read the current parameters from the drive? Well, of course. That way, when we write any changes we make here out to the drive, it'll preserve whatever was already in the drive. For example, the software defaults to the L7P drive. When we hit OK, we see the correct drive is now displayed and all the drive information is updated. You can load a parameter set from your PC, and you can reset all the parameters in this software to its default. Now, I don't want to do that because it'll reset all the parameters we just loaded from the drive. Hit Next to go to Step 2, Encoder Setup. Now we want to automatically detect the motor's encoder, but if you want to use an external encoder, you would manually set that up here. It's rare that you would want to do that. Next, choose the drive's mode. There are separate videos covering these modes. For now, let's just assume we'll be using the pulse input. Next, it wants to know what kind of pulses to expect. AB phasing, also known as AB quadrature, clockwise counterclockwise, or step and direction. These are the same, but the signals are swapped. Let's assume we'll be using pulse and direction. You can filter the input signals and select how the position following error gets reset. Next. You can easily change the motor's rotation direction. This is like swapping two of the motor leads, except it does it digitally by swapping the waveforms. Next. Notice that as we go along, this tells us where we are in the process and shows us the options we've selected. You can back up to any of those at any time. This is where you can set up electronic gearing. This is for when you want to send the encoder pulses out to other devices. You can send those signals out via line driver and also open collector. and specify which phase leads the other one. We're not using that, so we can skip it. Next, you can specify how the e-stop affects the drive. Do you want to use dynamic braking to stop the motor or use torque control? If using dynamic braking, do you want the brake to stay enabled, only use it to temporarily stop the motor, free run to a stop, or free run to a stop and then apply the brake? Having options like this are what make this servo system flexible enough to service such a wide variety of applications. Just remember, this is dynamic braking, where the motor's regen is used to slow the motor down by dumping energy into a resistor that you plug in here. Mechanical braking control is covered on the next page, where you can specify the timing of the braking and how long you want the PWM output to continue after the drive has been told to turn off. You would normally use this to briefly hold the motor in place while the mechanical braking is activating. This is driven from a digital I/O through a relay. Next, you can limit the torque different ways to help protect your machinery. You can have different limits for the different directions, or the same limit for different directions, use an external torque limit, both internal and external, or even analog torque controls. Let's choose the one that says use the same limit in both directions. Next, you can specify the timing of your position controls. That is, when you set up digital outputs to tell an external controller when the servo has reached its destination via this in position 1 and in position 2, you can tweak the timing of those digital outputs. There's a good description of that in the drive's user manual. Next, this is where you assign your digital inputs. In our hardware video, we used input 9 for e-stop, which is active low, and 7 and 8 for the positive and negative over travel limits, also active low. There's lots of things that digital inputs can be used for. And if you mess up, you can always restore these to their default values by hitting this button. Next, you can assign digital outputs. Here's that in position signal we were talking about, for example. And it looks like output 4 controls the brake, if you have a motor with a brake. We don't, so I'll make that not assigned. Next, this is where you specify the homing method you want. That's a big subject, so there's a separate series of videos on homing to walk you through this. Just know that this servo has lots of homing options. Next, and we're done. Of course, you can save your work and write the results to the drive. Now that's important. Nothing gets sent to the drive until you hit this write button, so don't forget to do that. Well, that's all there is to configuring your drive. I love the way this wizard just walks me through it step by step. And again, this was just a quick walkthrough. There are videos that show you how to set up each of these options depending on which operating mode you're using. This bar up here gives you a bunch of tools so you can manually monitor and verify different operations. When you click on one, you get a dedicated dialog over here. You can do this indexer test, a point-to-point move, jog the motor, we'll come back to that one, torque control, play with homing, auto-tune, yes, there's a video on auto-tune, and digital inputs. If I push e-stop, yep, this lights up showing e-stop is active. I can see exactly what each analog input is doing and how I currently have it set up. Digital outputs, where I can see how they're set, and I can even force an output if I want to. And an analog monitor. Over here, you can save the parameters, reset the alarms, reset the drive's controller, and do a firmware update. And you can even issue an e-stop. These guys give you drive status. You can view all kinds of things on the built-in O-scope, monitor the drive status in real time, velocity, position, torque, overload, encoder status, and general stuff, and see what's in the LED display and even change what the display shows. Let's look at the DC bus. Give it a second to catch up, and there it is, both here and on the drive. You can see the motor details and monitor the encoder. More drive stuff like gearing and braking and e-stop, torque, and indexer. Fault monitoring. Block diagrams with real-time values. Here's the PID loop, for example. A parameter viewer, which you can view by category by clicking on these blocks. Let's look at the I/O parameters, for example. And an indexer configuration. This L7C Servo Configuration Manager software is incredibly comprehensive. And again, it's a completely free download at AutomationDirect.com. So let's go back to the jog command. Let's tell it to do 60 RPM, or 1 revolution per second. Now make sure you hit enter after doing this or it won't take. If the text is red, it hasn't been written to the drive. I'll hit enter and yep, the red text goes away. And these rates are fine. Make sure we have the correct drive and it's connected to USB. Enable the drive's output and hold down the forward direction. And yep, the motor starts spinning. Hold down the negative direction and there it goes in the opposite direction. Jog is a super quick and easy way to tell if your servo system is wired up correctly. Well, great. Given this basic understanding of how the Drive Configuration Manager software works, you're now ready to do something productive with the system. So click here to see a playlist of all of the available L7C servo tutorial videos. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to this YouTube channel and hit that little bell icon so you'll be notified when we publish more videos like this one.